Hi everyone, uh, welcome to the next lecture of quantum mechanics. Give me 2 seconds. At the moment, I'm extremely sick. Like I thought that it would be good and stuff like that, but it's not. That's why you'll see my nose snorting and then me coughing all the time. So I'm extremely sorry. Anyway, so we start off with the next lecture. Probability. So let's just have a quick recap on what we have learned previously. So we know that we spoke about the wave function, we spoke about the probability, we spoke about the probability density, we spoke about everything, like the Schrodinger equation, everything in between. Let's do probability in two different. Now I know you can already see that. I'm pretty sure you know this example already, so honestly not surprised. But in a discrete variable, to find the probability in a discrete variable, probably this will be a short lecture, but let's just use the example which is already in the book. Let's use that only. So let's have number of students and age. So we have 14, 15, 16, 22, 24, 25, like you can see here. 14, 15, 16, 22, 24, 25. So we have 14, 15, 16, 22, 24, 25, which is 1, 1, 1, 3, 2, 2, 5. So 1, 1, 3, 2, 2, 5. And how do you find, like, what do you see? You see the number of students, you see the age. To calculate the total number of students, you'd add all those, right? So you'd have 1 plus 1 plus 3 plus 2 plus 2 plus 5. So you'd have 14 students. Simple. Total students. And then you have the probability that, the students will be aged 14. You do it 1 by 14 plus 1 by 15, 1 by 16, 3 by 16, 2 by 22, 2 by 24, 5 by 25. Don't try to, do this simplification or whatever. Don't do the simplification. Okay, it's not addition. It's just simple, individual value, individual probability. So 1 by 14 is for 1, 1 by 15 that's for the 15, and then 3 by 16 that is for the 1 by 4, 1 by 15 to the 1 by 14 for the aged 15, 3 by 14 for the aged 16, 2 by 14 for the aged 22, 2 by 14 for the aged 24, 5 by 14 for the age 25. And when you add them, everything will be 14 by 14, which is equivalent to 1. Right? Now, how do you get the median? So, which is the most probable age? This one. So, let's say if I were to draw this number of ages in a graph, this will be discrete. So, I have, let's say, 1, 1, 3, 2, 2, 2, 5. So you can see that the kind of like this, right? So the highest probable value is the aged 25, right? So we got the most probable age, we got the solution, we got the probability, and we know that the total probability will be equivalent to 1. That's the discrete part. How do we calculate the average? How would you calculate the average? So you would have average or mean would be number of people aged 14 is 1 times 14, 1 times 15, 3 times 16, 2 times 22, 2 times 24, 5 times 25, divided by 14, which is 294 by 14, which is 20. So long story short, you multiply the number of students aged at, so this is n of j, and this is j, n of j, j, n of j, j, n of j, j, and this is the total total n of j, sorry, not total j, total n of j. So this is the total number of students. This is the number of students aged 14, number of students aged 15, number of students aged 16, number of students 22, 24, 25 divided by the total number of students. Right? Now, general. So total number would be 294 by 14, which is 21. This is the average. Average, right? General average or mean. Now, how do you calculate the average squared? How do you calculate the average square? I'm sorry. To calculate the average square, you'd have j squared p of j divided by 14. Now, what do we know about j? What do we know about j? J is the number of j is the age itself, so you'd have, which is 14 squared times 1 by 14, or 14 squared times 1 plus 15 squared times 1 plus 16 squared times 3 plus 22 squared times 2 plus 24 squared times 2 plus 25 squared times 5, everything divided by 14. So you're going to get your average square. Average square. Whatever the solution is. Right? Whatever the solution is. J is the number of age, P of J is the number of students aged. So number of students aged 14, number of students aged 14. Number of student age 15, number of student age 16, number of student 22, number of student 24, and so on and so forth. Right? So to calculate average square, it is simply age squared times the number of students for that age. You divide by the total number of students. Total number of students. And the average would simply be age, number of students for that age, number of students for that age divided by the total number of students. Right? And to calculate the variance, your variance would be average square. So this is not average whole square actually. This is average square. Not average whole square, but average square. Average square has a value, average of whole square is a different value. So average square minus average whole square. Okay. So your variance, let's write it down again. You would have average square minus average whole square. And your STD, which is standard deviation, would be square root of this equation. So this is standard deviation. This, so I'm just going to highlight that in red. That guy there is variance without the square root, and this guy there, no, this guy here with the square root will be standard deviation. It's actually thinking 2 plus 3. It's reading this as 2, it's reading this as 3, that's all. Now how would you do that in the, so this is discrete point of view, which is usually used in classical mechanics. So this is for classical mechanics. Now in a continuous point of view, which is quantum point of view, where you will have decimal points and all that stuff included, you won't be able to use discrete equations in a continuous variable. Instead of doing this calculation, so instead of doing this age squared times number of students for that age divided by total number of students, you'd have j square is equal to j square psi of x psi conjugate of x, or you'd have j square is equal to j square psi of x whole square. After all, this is a probability, right? And when you find the probability, there should be expectation value. This is what you call expectation value. Not this specifically, but if you were even this is expectation value. Expectation value, expectation value, right? And to calculate the expectation value of j square is simply, but in reality, you write it in the form. This is a darker color, so if j square, actually this is a lighter color. So j square would be integration from a to b, like some value a to b, psi of x j square psi conjugate of x, and it will be the same thing for j, which is a to b psi of x j psi conjugate of x, and everything is the same thing. To calculate the variance, you would have j square minus j whole square, and STD would be j square minus j whole square squared. Right? Now, unlike here, to find the probability, you would add, like, you do that 1 by 14, 1 by plus 1 by 15 plus 1 by 3 by 16 plus so on and so forth. That's only applicable for discrete. You can't do like 0.8 by 14, or you can't do 13.5 by 14. You cannot do that in a discrete point of view. You can't use discrete equation in continuous values. Instead, we would do p of x is equal to plus infinite minus infinite p of x, which in this case will be equivalent to 1. This is what you call normalization. But in general case, p of x would be a to b p of x dx, always a dx. Why do we write dx? Because if I look at a graph, let's draw this graph. So you see that it's not bar graph, it's more of like a line graph. You're trying to add all the infinitesimal sections, right? You're trying to add this is dx, 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 all those are dx, and you're trying to add all those dx and finding one whole solution, right? So that's it from section 1.3. Next we're going to do a few questions. So 1.1, 1.2 and 1.3. Even though 1.1 and 1.2 is not really necessary because you have to look at the figure, we're going to directly start off from 1.3.